leadership in the development of AI, data, and robotics technologies. So the event will draw on key research and innovation priorities that we need to respond to societal challenges, support our economic prosperity, and also respond to the need for that progress to be aligned with reduction in energy efficiency and also the reduction of CO2. So Europe's digital decade is an ambition to close the technology development and skills gap across the Union and ensure that everyone can gain access and use this technology in a democratic fashion. Europe has to be able to capitalize on the market opportunity here and ensure that that technology is also developed with enshrined and core European values. So where no one is left behind, everyone enjoys those freedoms, protections, and fairness. In parallel to all of this, and over the next 2 decades, Europe will need to deal with climate change, a demographic shift, a reduced career ratio, lower productivity, urbanization, global competition from China and the US, all simultaneously. And that's without the impact of black swan events like the Ukraine war, for instance. So we have to be prepared. There is also huge potential from the use of these technologies. So renewable energy technologies, biodegradable plastics, new material discoveries using artificial intelligence, electric autonomous mobility. They all hold immense potential to improve people's lives and significantly accelerate efforts to achieve the Sustainable Development Goals and also, once again, to address climate change. So in order to help solve some of these challenges, at least, Adra believes that there needs to be very close alignment between public and private sectors. And this could indeed, done properly, could be Europe's superpower in the context of these global challenges. So Adra was founded to be the private side of a public-private partnership with the European Commission. It was founded by 5 associations, BDVA, Robotics, and 3 AI associations, Claire, Ellis, and Adra-e. The European Commission, on the public side, have invested 1.3 billion euros into research in these sectors through Horizon Europe funding. This means that the EU launches hundreds of projects in these sectors across the 7-year period, and with numerous projects running already. And the private side commits to match this with an equal sum of investment. So coming back to the event today, some of the things that we're going to be covering, and I'll pass over to my colleague Christoph in a moment to go into some more detail. But we have 3 blocks that we'll be looking at. So European strategies in AI, data, and robotics. So it will review Europe's current position, discuss and touch on the increase in competition globally, and why AI, data, and robotics technology is essential to this economic prosperity and the importance around intelligent systems for all industries. Block 2 will focus on AI, data, robotics, and environmental issues. So in particular, this kind of paradoxical situation that arises from the use of ADR technologies and on the other hand, and their potential in solving challenges, but on the other hand, their kind of high energy consumption in their current form and how this could be mitigated in the future. Block 3 will focus on public involvement and normative issues. So in particular, the need for legal, ethical, and regulatory measures to ensure its ethical use and prevent misuse. And then we're also going to have a couple of sessions throughout the day to introduce some of our exhibitors. So these will be successful demonstrations of several demonstrations of successful interactions between the 3 technologies, and also will give us a little bit of a glimpse at some of those easy funded projects that the Commission is funding, working really on the frontiers of progress. And then finally, to wrap up the whole day, we're going to have a foresight panel that will bring together the outcomes of those 3 sessions and also outline a little bit kind of some of the key recommendations and especially with regard to the research innovation priorities that we'd want to be focusing on. So at this moment, I just want to welcome you once again. Thank you very much for joining. And I pass over to my colleague, Christophe Leroux from CAR, who's going to talk a little bit about the methodology and go into a little bit more detail for the on the European Convergence. Thank you.
Hello, everybody. So I'm Christophe Leroux from CEA. I'm also part of the board of directors of this Adra association, interested involved in the co-program partnership on AI data and robotics. And I'm pleased to welcome you to this first Convergence Summit on AI data and robotics. So this is organized in the context of the activities of the Adra Association in charge of, with the EC, of the co-program partnership on AI data robotics. And this event is meant to be complementary to the event that are organized already on these questions and on the orientations of the research and innovation in AI data robotics. So it's complementary to the event organized by ADR, like the IDR Forum, the EBDVF of BDVA, or the ERF organized by eRobotics, as an example. The objective of this Convergence Summit is to contribute to the definition of a policy for research and innovation in technology, and something on which all the European community agrees upon. And the goal today is to reach a consensus on the way the combination of these ADR technologies can contribute to the objectives of decarbonization, interesting the European Commission and the European Union by 2050. The principle of this Convergence Summits to reach this consensus is to gather experts in different sectors with different point of views, experts in technologies involved in ADR, specialists in political issues, orientations in the member states, in the EU, organizations involved in policy making, and also, of course, organizations representing or that could say a word about from the citizens, representation of a social perspective. So multiple point of view that can express the challenge, that will express the challenges about how to reach this decarbonization objective by 2050, and experts that will analyze the acceptation by the population and what is feasible and compatible with this objective of decarbonization if we develop AI data robotics technologies. So as Philippe said, there is several sessions with different focus. 3 sessions that Philippe has already been talking about to investigate the questions in a political, according to a political aspect first, a technical aspect, and a more social aspect in the last one. And we have a 4th session, the 4-side panel, which will be the opportunity to conclude and to elaborate a consensus message, or to draft a consensus message that should represent a position from the stakeholders interested in this ADR technologies research and innovation, and to reaching this decarbonization objective. So I'm very pleased to welcome all the speakers, the panelists and moderator, and thank them for their involvement in this first Convergence Summit. And before starting the sessions, I would like to pass on the floor to Tanguy Kunen from IMEC. So Tanguy will present the effort conducted in microelectronics. So some technologies which are important and are very much connected to AI, data robotics, and that can contribute also to stimulate research and innovation. And I will also, well, I let Tanguy explaining and presenting this context, this general context of that is investigated in microelectronics. And so thank you very much anyway for all participants. And Tanguy, the floor is yours whenever you want.
Yes, thank you, Christophe, and good morning, everybody. So indeed, I'm Tanguy. I work at IMEC. I'm a scientific lead in the data tech program there, in a department called AI and algorithms. So thanks a lot for the invitation to speak here. It's a great honor. So what are we going to discuss today? First of all, a brief word about IMEC and what we do. Then a bit of an insight in some novel approaches that we see from research on energy efficient AI hardware, both let's say fundamental paradigms as well as some advances in edge AI. And then the second part of the presentation will be about greenhouse gas reduction in semiconductor manufacturing. So first, a quick word about IMEC and what it is that we do. So as all organizations, we have a mission statement. We are an RTO, a research and technology organization that is operating out of Belgium. And what we aim to do is, well, we are a world-leading R&D hub. And we make the bridge between academia and industry, you could say. And we want to work on disruptive innovation. And we want to do this by creating new solutions that are sustainable and that enhance quality of life. So you really see that this sustainability aspect, which we'll talk about today, is really at the core of our mission. So we operate from Belgium, as I said. We have 95 nationalities, so have people from all over the world flying in to work with us. Our crown jewel is our clean room, which is located at our headquarters in Leuven. It's 12,000 square meters, and well, it's filled with the latest equipment that you need to create the newest version of chips, basically. And we have companies from all over the world that come to our clean room to experiment with all of these tools and all of these new processes to be able to create all the next generations of chips, which you will see in the next 10 to 15 years. So we do this with a lot of companies, and we can do this because we are seen as a trusted partner, because we've been doing this for 40 years. We're celebrating our 40th anniversary this year. So we work a lot with companies, we have startup programs, and we also work a lot, of course, with academia. So we have an innovation platform. That means a number of, let's say, puzzle pieces that we use to create our innovations. I think we're most known for the bottom left part, which is about all we do regarding the development of new hardware. So we do this in our core CMOS program. We also work on flexible technologies and a lot on sensor development. So a lot of new types of radars, lidars, cameras, different types of sensors that are to be deployed in different types of industries. Of course, all of these sensors, they produce data. So that means that you need to be able to network the data, you need to secure the data, and you need to analyze the data. So we also have a big department working on AI. We work in a number of sectors, which you can see in the top part of this picture. So a lot of work on health. Also a lot of work on mobility, cities, industries, energy, education, and so on. So what is it that we currently are seeing as, let's say, top of mind in the world of energy efficient AI? Let's dive into that for a moment, because, well, I think arguably the last 5 years in the IT industry have been, well, all about AI. You could say there is a lot of concerns, though, about how much power or electricity it takes to train the AI models, and also how much electricity it takes to do the inference for things like, for example, ChatGPT. There's also a lot of concern about the power usage of data centers. I think it was yesterday in the news that in Ireland, there is some concern about the fact that there are a lot of data centers in Ireland. That's a great thing for Ireland, but also it's using a lot of energy. And that is not always a very, let's say, a positive thing for a country. And these concerns have also been voiced by other countries, like, for example, the Netherlands and France, where there are also a lot of data centers. So I think we've been doing quite well in terms of the energy that we need to run our AI models for a long time. And we saw time to increase every 2 years, let's say. But since the end of the last AI winter, we really saw that this has been increasing quite a lot. So we now see a 100-fold increase every 2 years, because we are making our systems larger and larger. And so the question is, where will this end? We need to manage the amount of energy that we are using for doing AI. So the way in which IMEC addresses this is by creating new applications, new hardware platforms, which follow, let's say, this acronym. So these are 5 letters that are at the core of the innovations that we strive for. So the first P stands for power. We want to make these things low power, but also we want to make them more performant, because that's also an important element of, let's say, Moore's law, the performance of the semiconductor systems. We want to make them smaller. That's what area is about. And we want to make them low cost, because, of course, cost is always something that you need to take into account in all industries. And also the last E is about environment. So we want to make sure that the environmental impact of these innovations is also taken into account. And, well, these 5 elements, these 5 dimensions, if you will, of course, well, they represent trade-offs, right? You can sometimes make things that are very performant, but that will then cost a lot, and that will then, for example, not be very beneficial for certain types of applications. So how do we do these innovations? How do we go about them? We apply a system called, or a methodology called, system technology co-optimization. And that really is about making sure that the top part of this picture, which is about understanding the application domain, is, let's say, taken into account very thoroughly when looking for new computational platforms, which is the bottom part. And so in the top part, we look at certain industries where we want to make new types of innovations, for example, machine learning innovations. And then we make sure that we can obtain hardware solutions, very low-level hardware solutions that are attuned to this type of applications, so that we don't really need to run everything on CPUs or GPUs, which are, let's say, general purpose compute platforms, but that sometimes are not the best fit for certain types of applications. So what is it then that we see in terms of novel hardware paradigms? So we're seeing a drift away from the classical compute architectures, which we've been using for a long time. And you've got your CPU, your memory, your I/O, and your bus in between. We're going more towards domain-specific architectures where, as I explained, the compute is very much attuned to the domain in which you operate. And very often, if you want to do AI-related things, then you need to have a lot of, well, parallel computations. So we know one device that does this very well. That is, of course, our brain. So therefore, we are looking a lot at brain-inspired computing. because the brain is doing a lot of calculations. 1 exaflop at 20 watts of power. We are able to do that now with AI, but at 20 megawatts of power. So that is 1 million times less efficient than our brain. So why is that, you may ask, and how can we make sure that we build something that is, well, as efficient as the brain? So for that, we are at the moment working on something called neuromorphic computing, which is an approach that uses a type of neural network that is called a spiking neural network. So this is a bit different from the neural networks that we've been seeing in large language models and other types of AI applications. Where these systems, they have a neural network and they exchange weights, which are numbers basically. And they do this in a, let's say, there's a lot of numbers being exchanged. So it's not a very sparse network. Whereas with spiking neural networks, basically you send electrical spikes through the network in a much more sparser way. So there's a lot less computations going on. So that makes it much more energy efficient. We've been working on this for a while now. We've built 4 generations of these chips, of which Argus is the one that we're currently using in well, let's say prototypes, and the Seneca chip is one that is being designed and soon to be released. This is an example of an application that we made in this area. So this is very interesting if you want to take a sensor and you want to make it smart. So you have a very low power chip. Of course, these spiking neural networks at the moment, they are not as powerful as the GPUs that are out there, but you can do some interesting things with them if you combine them very early with a sensor. For example, here, you see a combination of the 140 gigahertz radar, which we developed, together with a spiking neural network chip to do gesture detection. And here we got a 90% accuracy rate at 42 nanojoules per inference, which is, well, a pretty good result. It doesn't use a lot of power, that means. We're also looking at other use cases like object detection and audio keyword detection, so keyword detection in speech. We have a roadmap for further developing this. So if, as you can see at the bottom left part, this is a lot about hardware algorithm co-optimization. So where we look at the algorithms that are out there, and we try to make sure that we can design the hardware that can run on these algorithmic innovations. And then we're also trying to make these things more user-friendly so that other organizations can also use it by building software development kits and so on. So that's it for neuromorphic. We're also looking at superconducting or cryogenic computing, which is, let's say, a type of computing that is being done at very, very, very low temperatures, so close to 0 Kelvin. And what happens then if you cool these systems is that they become superconducting. So that means that the resistance of your circuits goes down. That means that you can actually do, let's say, computations at a much more energy efficient rate. So we're seeing promising results there. Not only can your computations be done at a much more energy-friendly rate, but also you can make your systems much smaller. And so sometimes we also call this the data center in a shoebox, because you can really put a data center in a very small box. So this is something that we are looking at a lot. And last type of innovation is probabilistic computing. So you all know a bit. So a bit is something that, well, you use daily because it's in your computers, and it's how classical computers work. A bit can either be a 0 or a 1. You may also have heard of qubits, which is let's say the element of computing which is used in quantum computing, which can be a 0 or a 1 at the same time. It's a superposition. But there's also something called a p-bit, probabilistic bit. And this is a bit that can flip between a 0 and a 1 according to a certain probability distribution. So that means that You can do new interesting things with that because we've developed a magnetic turnable bit. And so the flipping of this bit requires no or very little energy. So it's a very energy efficient way of doing computations, but it's also a type of application that we are still building the algorithms for. So looking at, for example, wayfinding in autonomous cars, because then an autonomous car needs to find its way, needs to look at different types of probabilities, which is what a p-bit can represent quite well. And we could then be able to do wayfinding for cars at a very energy efficient way by using this probabilistic computing paradigm. Okay, so these are a number of more low-level hardware innovations, but we're also looking at edge AI. Why? Because, well, again, cloud computing is using a lot of power. If we do not manage this, this will become a big problem. And we're seeing a lot of we're seeing a lot of activity in the edge sector at the moment. So we've been doing 20 years of cloud investment, and that's really great because it gave us great systems. But we also see that there is a big race going on at the moment at different vendors of consumer electronics, like Apple, Microsoft, Samsung, and so on, to put more chips, AI-capable chips, in their consumer devices. We recently saw the launch of the Microsoft Copilot Plus PC, which is a Windows PC that has ChatGPT-like capabilities built into it, so it can constantly learn from what you're doing. There's also the innovations from Apple with its M4 chip, which will come into, for example, the latest generation of iPads. So we will see more AI applications in the coming years that are using the data, the personal data, the sensitive data of people. So that means that probably there will be a lot of AI assistants that come out. One of the big plays, the first, let's say, stake in the grounds that have been made there came out last week by Apple. It's called Apple Intelligence, and it says that they are looking to have more AI applications run on people's devices, like the iPhone or the iPad. And they know that this will not all be running on their end devices. It will not all be running on their edge iPads and iPhones. Sometimes they will also need to send data to the cloud because not all large language models for the moment are able to run on an edge device. And so they are, let's say, preparing the grounds for having people feel comfortable to send their very sensitive data into the cloud. Are people going to want to trust Apple with that? So that's what that was all about. So privacy is also, I think, a very big thing at the moment. But this all illustrates that there's really a lot of interest and a lot of movement in the edge domain at the moment. And the edge, I mean, it needs to be sustainable because it's going to be large numbers of deployments. So it's going to come a lot to people's homes and in office spaces and so on. And we need to work on the sustainability of edge because this is just an example. But if you have a light somewhere in your home, and you want to turn it off by using something like Alexa or Google Home, and you say like, okay, turn off the light, then your speech is being analyzed. It's being converted into a command that then is being sent to the light to actually turn it off. Sometimes it goes through the cloud. It doesn't have to, but if you do this, then just by using this kind of way to turning off the light instead of pushing the good old-fashioned light switch, then you use as much energy as having the lights turned on for 1 hour. So if you do this, if you use this approach 4 times a day, that means that you are using 4 hours of light in your house. This is just an illustration to indicate that, well, edge is good, yes, but it also needs to be sustainable. So to make sure that this is sustainable, we are working on a program called the Private and Sustainable Edge Compute Program. So that means with edge, extreme edge, we mean an edge network that uses as little of the cloud as possible. So yes, Apple wants to send a lot of cloud data, wants to send personal data to the cloud if necessary, but we are asking ourselves, can we not do as much as we can in the edge? And in this case, that would mean at people's home. And so do we really need the cloud for all the applications that we are using? Can we not have, for example, these AI assistants that are using large language model, fine-tune and do inference basically at people's homes without sending the data back and forth to the cloud? That would solve a lot of privacy issues. And it would also allow you to do things like scheduling the fine-tuning of your AI assistant in a way that is sustainable, because you would then be able to train or to schedule the training of these large language models in a way that it reuses the renewable energy that is at your disposal. Because quite a lot of homes are already equipped with solar panels or will be in the coming years. So that means that if you would look at this kind of an extreme edge network and you would have an AI that would be running in your house, then this AI needs to be trained from time to time or fine-tuned. But then you could say like, okay, if I have a lot of renewable energy coming from my solar panels, I can tell my AI that yes, it can do a lot of training because this uses a lot of energy. But if the energy that is coming out of my power socket is not renewable, then I may ask my AI to tone it down a notch and then maybe train at a later point in time. These are the things that we are currently developing in this program. And we just released a prototype 3 weeks ago at our ITF event of an HVAC reinforcement learning agent. So that's a reinforcement learning algorithm that does the planning of HVAC, so the cooling and the heating of your house. And that takes into account the way in which your house is being used. And that can also predict how your house is being used. So who will be where at what moments in time, so that the algorithm can really understand how it needs to heat or cool your house. And this training of this algorithm was done by taking into account a prediction of the amount of renewable energy that would be available at some point in time. Good. So that's about the hardware innovations that we see. Now, the second part of my presentation is more about greenhouse gas reduction in semiconductor manufacturing. So this is a picture that is from Boston Consultancy Group, and they studied how the semiconductor industry is doing at the moment. In terms of, well, reduction of CO2 emissions. So the bottom line is what the predictions are by the International Panel on Climate Change, the IPCC, to get a 1.5 increase in temperature. The top line is what will happen if we do nothing. And the middle line is what will happen if everybody that has pledged in the semiconductor to do something about this semiconductor industry will actually live up to their pledges. And you see that there is still a big discrepancy between the second line and the bottom line. And so we really need to do more in the semiconductor industry to reduce CO2 emissions. And so that means that for any company in this sector, there needs to be an understanding of how they are doing in terms of CO2 emissions. And this is not a very easy thing to do because, of course, the semiconductor supply chain is a very long and a very complicated supply chain. It starts somewhere where raw materials are being mined, and it ends somewhere where somebody puts a smartphone in their pocket, and then afterwards, also after the lifetime of this smartphone, also the recycling of these materials needs to be taken into account. And so it's important for every part of this long and complicated supply chain, which is a global supply chain, that every actor in this supply chain understands how they are doing in terms of CO2 emissions. And at the moment, this is not easy because what we really would like to have is what they call primary data, which is real data that is being produced by real devices or real production facilities, by real factories or real trucks driving around to move freight around. But that's at the moment very, very tricky. So what we have developed at IMEC is a way to produce secondary data. So that means more approximated data. And we can do this because we are an organization that researches the semiconductor systems of the future. So that means that if you want to know what a sub 1 nanometer node, the production thereof will look like, then you can use a tool that we've developed called IMEC Net Zero, which has a number of process steps that you can configure so that you then will understand how much CO2 equivalent this new type of transistor technology, for example, will use in the future. You can do this for future technologies. You can also do this for current production technologies as a way to approximate the amount of CO2 that, for example, is produced by a fab. A fab is a factory where chips are being produced. But we would like to go more towards a situation where if you are a vendor of, let's say, mobile phones, and you want to understand how much CO2 has been produced by a certain chip that is in your mobile phone, and there's many chips in a mobile phone, so it's already a quite complicated question to ask. But if you would like to know how much CO2 has been produced by one chip, we would like to have a system where this vendor of mobile phones is able to make a request to its supplier of chips on the amount of CO2 that has been produced. And that requires data sharing. And for data sharing, we are looking at this concept of data spaces. I think that's a concept that has been heavily developed in the last 5 to 6 years in the European Union. I think we are doing well, very interesting things in that domain. And so the idea of a data space is that you create an ecosystem of organizations that are all able to share data with each other because they trust each other. And they trust each other because the data space has a number of rules that have been established, and the actors in this data space can be trusted to play by those rules. And so that means that if any two companies need to interact with each other, even if they don't trust each other yet, even if they have no pre-existing relationship, then they can engage in data sharing because of these rules that exist in the data space. So we know how to build these things. So they have been developed in the EU, as I said. There is a blueprint on that, which you can see here on the right-hand side of the picture, which has been released quite recently by the Data Spaces Support Center on how to actually build something like that, which is building on the reference architecture model of the International Data Spaces Association. So let's not go in detail on this drawing, but what we would like to do is to apply this kind of data space concept where you have a data publisher and a data consumer that are able to share data with each other. We would like to apply this to the semiconductor industry. And so that means that this is not a European-only story. The semiconductor industry is a global industry. We have the production of chips is quite often done in Korea or in Taiwan. The mining of materials is quite often done in Africa. The design of the chips is quite often done in the US. And well, a lot of the big system companies, so vendors of consumer electronics are in the US. So it's really a global story. And for that, we need to build a governance, a data space governance. So that means that one of the first things that we need to tackle is to get a number of companies together in a data space governance authority, this is called, who will together build the rules of the data space. This should be a multilateral exercise. It should not be an exercise that is, let's say, run by one company, because that, of course, will generate mistrust in the data space, because then it's only this one. I mean, it will be perceived as the initiative of one big company. So that's not the idea. It should be multilateral, and we should focus on data sharing, of course. That's the prime goal. Making sure that the data that is produced, the carbon footprint data that is produced, that it can be verified, that it has been produced according to certain standards. And of course, these standards need to be there. We also need to work on the onboarding on members. So companies need to be onboarded into a data space and need to, let's say, show that they are trustworthy actors. And then we also would like to work on a marketplace so that data sets and also applications, algorithms, AI algorithms or others can actually be offered within this data space to offer services to the different actors in that data space. This is, let's say, the essence of how this would work. I don't think we have time to go in detail on the nitty-gritty details of this sequence diagram, but we are about to release next week a white paper on how we see this work. Looking forward to engaging with you on the white paper. And that's what I had for you today. Hope you found it interesting. If you want to interact more, please drop me an email or, let's say, friend me on LinkedIn. So thanks a lot. Have a great day, and handing back the control to the organization.
Thank you. Thank you. Would you mind just hanging around for 1 minute, because we do have a question for you, but thank you very much for a fascinating presentation. And for anybody who hasn't seen the clean room at IMEC, it's very worth a visit. But we have one question that came in from Anissa Seifert. So the question is, Edge AI is indeed a very promising area. However, Tanguy, could you name European companies that are already active on the market? Are there any startups from IMEC that are already entering the market?
Well, I think there is, for example, in Flanders, there is an initiative which is it used to be called the Data Utility Company. And so this is a company, you could see it as a PPP kind of initiative that aims to be a utility company for data. So if you reflect on a utility company for water, that has a responsibility to make sure that water can flow. Electricity utility companies make sure that electricity can flow. So a data utility company has the aim of making sure that data can flow within Flanders, let's say. And so this company is now called Adra-e, and they are very much working on integration of things like the solid technology, which is like a privacy-preserving data pot or data store, you could say. And they're very much looking at how this can be implemented, for example, in people's homes. So that would be one example of such a company. But there's many others for sure. Also, of course, there is a lot of activities in the edge hardware acceleration domain. And so a lot of small startups that are popping up that are kind of, let's say, challenging NVIDIA, because NVIDIA also has a lot of, just became, by the way, the biggest company in the world today. I heard on the news this morning. So there's a lot of challengers also there that are creating new types of AI acceleration paradigms in the edge domain.
Great. Many thanks for your presentation, Tanguy. We are going to move on to the next section now. Thank you very much. And the next section will be our first block. And the first block is going to cover European strategies in ADR. So the European artificial intelligence, robotics, big data research and innovation players facing international competition. And I'd like to welcome to the stage Thibault. Thibault, if you could put yourself on, I'll introduce you in a moment. So Thibault Jongen from Generative Robotics. He is the former CEO of Sapka, a key player in Europe's aviation industry. He stepped down in February of this year after 7 years at the company to dedicate himself to innovation in industrial robotics. He's going to be discussing robots with common sense, and a new initiative, and the vision of repatriating and maintaining industrial production in Europe by replacing manual labor with affordable automation. So Thibault, we welcome you on the stage, and then I will, after your intervention, welcome the other panelists. Thank you very much. Over to you.
Okay, thanks a lot, Philippe. Just checking, can you hear me? Can you see my screen? Yeah, okay, perfect. So thanks a lot and welcome everyone. Good morning, everyone. I'm really pleased and honored to be able to give a keynote on this very important topic. So actually today I'm going to focus on something that is at the core of Adra because it really touches both the artificial intelligence part, the data part, and the robotics part. And actually I'm going to focus on one subset of ADR, which is the manufacturing industry. And actually in the manufacturing industry, I'm going to focus on yet one other subset, which is the manual labor within the manufacturing industry. And you will see, hopefully, understand that it is actually a key topic, a strategic topic for Europe, both in terms of its autonomy, sovereignty, societal values, but also sustainability. Now, of course, a picture is much better than 1,000 words. So I'm going to show you a little movie that will explain a bit the world I'm coming from, which is really the low volume, high mix, high value added manufacturing in aerospace. And you will see the making of two products that you see on the right hand side, which is the fairing of the A350 Airbus aircraft and the horizontal tape lane of the Gulfstream. Both are composite products, and this is taken from our factory in Belgium, in Flanders, where you can see this is the mold where the plies of the composite pre-impregnated carbon fibers are being put. And you can see clearly this is manual work. This is actually quite dexterous because this is just the first line of the liner before putting the composite. And this is what we call cumulative manufacturing because it takes somehow like 150 hours of manual work to be able to produce the product. If at the last hour there is a mistake, one of the person does a mistake, then of course the whole product is lost. So this is really accumulating value. And you need a lot of dexterity, you need a lot of coordination. As you can see here, we are putting the honeycomb between two layers of composite. Also requires a lot of interaction, coordination, common sense actually to be able to work it through. You also need to be able to position it more or less accurately. And there is, for instance, you will see on the shoulder of the lady some laser beams that are there to help guiding and positioning more or less accurately. This is the end product that is being baked, cured, and painted, and where there is yet still a lot of manual intervention, manual work, like putting stiffeners, putting rivets in the product. And again, these are all low volume product in the sense we produce something like 10 of these per month. This is the wing, which is not baked yet. This is a very big part in composite, but we also need to place afterwards, before curing, some stiffeners, some reinforcement bars that are also in composite. You can see here also the laser beam that is guiding the operator to place by hand the stiffeners, and even using like a tooling, like a spatula, is exerting pressure to be able to place it, and then it's baked. And you can see here another example of some manual work that happens during the production process to come to the end product, which is here, which is the full wing of the aft part that is fully cured and painted. And these are just a few of the examples of the world I'm living in, the world of SAPCA, which is basically low volume, high mix, high value added products. And you can see many of them on the left, for instance, you see on the top sorting some plies and putting them on the shelf. Bottom left, this is putting some masking tape before paint. On the right bottom, this is a F-16 aluminum wing skin that is being machined automatically, but the last step has to be done by hand because it requires some visual check of how polished this is, etc. So the characteristic of all this is that actually, as you can see, automation is rather complex, if not impossible. Complex or very expensive, and usually complexity and expensive go together. So basically, the business case isn't closed because the volumes are too low, or it's way too complex, too expensive to automate. So basically, the whole question is, what can we replace manual work with affordable automation? And this is very important because, for instance, I plead guilty because some of the movies that you've seen just before are not in Belgium anymore. I have moved a number of production lines in my industrial career to low wage countries like Morocco or Middle East. And this is just purely an economical aspect. And the question is here, how can we repatriate? How can we maintain production work, industrial production work in Europe? And as everybody knows, this is key, of course, for the sovereignty, the autonomy, the value creation, and the welfare of the European society. On the other hand, and you see a lot of progress in robotics. This is dexterity. You see a lot of artificial limbs, a lot of behavioral cloning, imitation learning, teleoperation, and actually this changes every day. So you check internet every day, there is a new thing. So amazing progress in robotics, amazing progress in dexterity, amazing progress in autonomy. At the same time, a lot of progress in AI technology, deep learning, generative AI, where actually you can couple the robots with a kind of a ChatGPT so that the robot can actually learn and imitate some tasks without having to have explicit programming. These are just a few movies, and again, this changes every day on the internet, showing how you can train a robot. Like for instance, on the right-hand side, this is a kind of kitchen robot. And you train it by teleoperation, by actually capturing as many episodes, as many data as possible. And then through the building of what is called like a robot foundation model, the robot is then able, based on multimodal prompting, text, speech, to kind of plan and autonomously execute a task, even in a new environment or like obstacles. So it can really start to reason and to plan and to adapt. So basically, our vision is to say, look, there is a need to replace manual work with affordable automation. At the same time, amazing progress and convergence between robotics, artificial intelligence. So isn't it time to actually assess, can we replace manual work in the manufacturing industry with affordable automation through a new generation of safe, dexterous, and intelligent robots? This is basically our vision, what we try to do with the Robots with Common Sense initiative. Now, what do we focus on the manufacturing industry? Well, obviously, it's an environment that is more under control. It's not like a kitchen in a house, in a home, and where you've got cats, you've got babies coming in. It's much more risky. Here in the industrial environment, it's under control. You have professionals, you've got processes, procedures, etc. Second, clearly, manufacturing industry is a high-cost and high-value industry, meaning if you want to replace manual work of, for instance, picking up apples in the field, well, then you are against, like 10 euros per hour, whereas in the manufacturing industry, you are more against 150 euros per hour. So basically, the business case is going to be easier to justify and to close. The same reason, usually when as industrialists you embark in an automation project, well, usually it's very expensive because you need basically to build a new plant, you need to adapt your processes, you need to adapt the definition of your product to the automation. Here we take the other point of view. Instead of adapting the world and the environment to automation, we adapt the robots to the existing world. So meaning that you can reuse the same assets, the same existing production line that you are using currently with manual labor, to replace it and to reuse it actually. So actually the capex, the investment is much lower, which makes it affordable, of course. And clearly, a lot of people say that Europe has lost the race against the US and China, for instance, for large language models, for foundation models, etc., etc. Well, actually, there is still a very, very important and big race to win, which is the industrial race. And there, Europe actually has a lot of legacy, has a lot of capabilities, has a lot of competencies to make it work and actually to win that race. And you can see on the little graph or the table in the middle, the manufacturing industry is a big industry. It creates a lot of value. And there is a lot of productivity. And you can see productivity in Europe is much higher thanks to actually the legacy of automation. But there is still, a lot of work, a lot of industries, a lot of companies, like 1/3 of them that still rely heavily on manual work. So there is a huge potential, there is a huge need actually to see, can we replace manual work with affordable automation? And we focus first on the aerospace because this is the world I come from, and this is actually where there is a high need for replacing manual work with affordable automation. But obviously, it's clear that being able to crack that nut for aerospace will open a lot of applications in many other industrial verticals like construction, food processing, healthcare, etc., etc. Okay, so as an industrialist, I've got a factory where I need to, for instance, put stiffeners on wing. I need to put to sort pre-cut plies and to put them on the shelf, and I need to put tape. This is just, of course, an example. Huh? It doesn't have to be like this. And then I would basically hire a number of robots robots that are safe, so that means that can be put within a human environment safely without having to build big fences around it. Those robots should be also dexterous, so they can replace the manual work that is currently happening, as I showed you before. And they need to be intelligent in the sense that they can be trained for a task, and they can even be retrained for additional tasks without forgetting the previous task. And this is called catastrophic forgetting. And obviously here we want to have cumulative memory, meaning that they need to be able to be trained quickly, like actually human operators, to be able to be deployed in more work. So perfect. So I'm happy as an industrialist, because I can now buy the latest Optimus from Tesla or any other anthropomorphic robot that is coming on the market. You've seen that China, they now sell some of those robots for $20,000, so it's quite affordable. So I'm happy, I just buy them and that's it. Well, not quite actually, because there is a big challenge that this needs to still be solved in what we call cumulative manufacturing, meaning that it's not just logistics, where you always repeat the same motion. And you know, if you have one motion that is not correctly done, well, okay, you lost a tomato and then you redo it again. Well, in cumulative manufacturing, as I showed you before with the illustration, it is not like this. You need to have some guarantee. So basically, what do we need? The first point to realize is that, you know, with the big hype of Gen AI, of deep learning, it's all digital to digital, of course. It stays in the computer. Here, we're talking about the embodiment, in the fact that actually the computer interacts with the physical world, can learn, can be trained, can actually ask, do tasks, act in the world. So it actually comes with many additional asks that we would have for the foundation models. The first one, obviously, is safety and trustworthiness. When the foundation model hallucinates, it's funny sometimes, but actually, if it's in the physical world, we cannot let it happen. It would have dramatic consequences in terms of, you know, interacting with humans or with robots. So clearly, safety, trustworthiness in robots that are using foundation models is a clear must. Second, you need to have guarantees, as in strong guarantees in terms of quality, repeatability, accuracy, because again, we cannot afford that, you know, after 100 hours of work, suddenly something goes wrong, and then basically you lost all the accumulated value. Then obviously data requirements, which are going to be massively more, because now you're not just, you know, in the digital world, you are in the physical world. So you've got time and space as well, meaning that you've got orders of magnitude more data. And those data actually are a lot, but are they available? Not as much as we have currently on internet for the foundation models and the large models. Standardization, how can we standardize it? How can we transfer it? So a lot of questions about data, data infrastructure, data quality. Then, of course, explainability, because in cumulative manufacturing, if you fail an action, you cannot just repeat it. You need to understand why it failed, because you need to be able to correct it. This is continuous improvement, but also actually, for instance, in aerospace, in pharmaceutical, you also need to have certification. So you need to give guarantees to the authorities that actually your process is under control and you know exactly what happened, because you can demonstrate is always going to be of the highest and the required quality. So that means if something goes wrong, you need to be able to learn and to explain. So explainability is key as well in cumulative manufacturing. Openness. Well, a lot of the foundation models, the large language models, are closed, are proprietary. We don't know really, they are not transparent. Well, first, that means that, you know, proprietary means that competitiveness is going to be more difficult. So the price probably are going to go high. So if you want to be affordable, you rather have an open models. But also if you want to reuse those models in other configurations, like for instance, you saw some of the robots that are just for illustration. These are like 3 arms robots, but actually it's not one robot with 3 arms that has been trained. That's actually 3 arms that are interacting. And those arms themselves are based on agents that are linked, the limbs of the arms. So that means that you need to be able to cut open the foundation models to the smallest atoms, I would say, the smallest components, the smaller modules, so that then you can reuse them in different configurations and you can even scale them up. So open foundation model is also a very important characteristic. And finally, they need to be frugal in the sense that the computational energy, the computational requirements, the energy that goes with that, the amount of data is just going to be unaffordable, again, in the physical world with time and space dependency and so many different applications. So these are very, very important topics that for the moment are not really fulfilled, requirements that are not really fulfilled by the current foundation models, the large language models. So these are key issues and challenges where, again, Europe can clearly also take a leadership role there. Now, one could say, look, for the moment, human operators are not perfect either. Huh? They forget, they are not so accurate. There is what is called the human factor, like, you know, sometimes they are not trained enough. Sometimes they don't have the right skills. Sometimes, you know, they forget, they are tired, they are under pressure from the management, things like this, and they make mistakes. Yeah, of course. And that's clearly why we've got all these political controls and processes. But also because we believe and we rely on the common sense of people to be able to learn, to adapt, to improve. And actually, if you are wondering why, this is why we call this initiative Robots with Common Sense. And actually, it's robots with industrial common sense. So basically, common sense, what is it? It's a kind of interaction standard between human beings. Unless people are psychopaths, it's a way to be able to know that you can interact. You can have someone in front of you that can reason, that can plan, that can act, that can adapt, that can make decisions. And there are four main characteristics of common sense. The first one is empathy, the ability to intuit and to understand what the intention of the other is. Second characteristic is knowledge of the physical world, meaning actually knowledge of space and time. Third characteristic is causality, ability to make relationships, causal relationships. This is fundamental to be able to learn, to reason, to adapt to new tasks. And the fourth characteristic is actually norms, social sense, trustworthiness. Again, unless you're a psychopath, you know that your counterpart is going to do everything to protect him or herself, but also not to attack you. So basically a kind of a non-social sense. So having robots with common sense, this is a dream for many, a long time. There's nothing new. Isaac Asimov was already dreaming of that 8 years ago. Here we take a subset where we try to see, good, can we have industrial common sense? Basically, when I hire people, I don't hire them from the street. I hire them from a technical school. So I know that when they come to my factory, they have common sense. They've got industrial common sense. I know that when they see, like, you know, an image of someone with safety glasses, I know that they know it means you have to wear your safety glasses. I know that they won't take a hammer and start banging on the product. You know, they've got common sense. Huh? They know the obvious stuff. Well, actually, we try to do the same in robots. Can we have robots with industrial common sense? And basically, I'm going to go fast here, but this is gives you a little bit more details about, you know, the challenges. The digital to digital, so the foundation models as of today, you know, they take inputs, text, speech, image, etc. Then they tokenize it. And then with a transformer, this is the T of the ChatGPT. This is a transformer actually predicts what is the most likely next token, and then it detokenizes and allows actually to transform text in a language A to text in a language X, Spanish to French, whatever, or image to text, like, you know, capturing. Great. And this is based actually on digital information, data that is already available on internet, and is taking billions and billions of data. The robots foundation model kind of work in the same manner, but in the physical world, with a world model where they take perception, so inputs of where the robot is in the world, and actually codes this in an event, and then based on the training data, predicts what the most likely event is, the next most likely event is, basically the next action to take, according to a goal to reach, and then translate it into motor actions and basically motion. Perfect. Well, the data is physical. So as I said before, much more data, time and space dependent, but also it's like first-person data. It's like pressures, sensors on the fingers. How do you standardize it? How do you code it? How do you transfer it to someone else? These are big questions of data standardization, data transfer as well. And of course, if we go back to common sense, well, foundation models, large models can be kind of, you know, empathy in the sense that they are multimodal. They've got some intuition. Physical world, again, linked to the properties of common sense. Yes, the robot foundation models have that, but there are still two characteristics that are missing. It's the trustworthiness. It is the causality. So explainability, trustworthiness, safety. This really, as I mentioned before, are constraints that we need to have on robots in the manufacturing world, in the manufacturing industry. And those are not, for the moment, achieved with, you know, all the deep learning on the Gen AI. So what we are trying to do is actually to put a constraint with explicit knowledge, with knowledge that we have, with obvious stuff that we would actually, in a symbolic manner, put into the system. The illustration we always take is like, you know, the foundation models, the robot foundation models are like wild horses. They've got a lot of power, they can do a lot of things. But, you know, if they are not tamed, they cannot do useful work because they cannot be predicted. They are wild. So basically what we try to do is to tame the wild horse so that we can transform the power of the horse into useful work. And this is done with, of course, what now becomes more and more relevant is what we currently say call a neurosymbolic AI, which is actually a combination between like deep learning and symbolic AI. And again, here, Europe has a lot of capabilities, a lot of competencies, a lot of things to do. And this is really an area where I believe Europe can take the edge, again, for autonomy, but also then for sustainability, as we will see later. And again, things like, you know, reinforcement learning and other methods in AI are clearly going to be on the horizon. Now, to explain you a bit more maybe what the challenge is, I'd like to make an analogy where we all dream about, you know, replacing the human driver with autonomous pilots. And basically, you go in a car, you don't drive, and you go safely and with a guarantee from point A to point B. This is the vision, this is the ambition, but clearly we're not there yet today. As you know, except in very specific cases, there are no autonomous cars for actually the same kind of reasons as the one I mentioned before: trustworthiness, explainability, guarantees, things like this. And then you've got a whole sequence of, you know, levels of autonomy, starting from level 0, and the first 3 levels is actually human in the loop. So there is a driver that makes decision, but then it's helped, it's assisted by the computer. And then the last 3 levels, 3, 4, 5, is the computer that takes basically decisions, and then the human is just there to, you know, as a backup. And you've seen the evolution of, you know, technology. We started with GPS, and then, you know, assisted driving, like for instance, in a known environment like a highway, well, helping, assisting the driver by doing simple tasks, and sometimes also taking authority. Like if the driver does something dangerous, actually the computer takes authority and saves basically by braking automatically. Well, we want to do the same with automation, basically, in manufacturing. So basically, it's the levels of manual work in manufacturing, where we also try to have, you know, a graded approach. So the goal is to replace manual work with affordable automation. This is the end goal, but we also try to have a stepwise approach because the end goal for the moment is just not reachable for all the constraints I mentioned before. So quickly here, what we would try to, or what we are trying to develop now is what we would call the GPS of manufacturing. So the first step, basically. So it's just about knowledge. When we hire people from schools to come to work in our factories, basically we know they have general industrial knowledge available, and then we give them onboarding documents like company-specific knowledge, like process manuals, organization charts, quality manuals, procedures, things like this. And then they are trained to work on a specific task, like for instance, doing some composite fabric for aerospace. Then they've got the instruction manual for the specific product. Then together with on-the-job training, where they observe first and they start doing the stuff themselves, well, basically we build safe and dexterous operators that have more and more skills and more autonomy. Well, what we want to do is kind of the same for what we call the silver-collar workers and not the blue-collar workers, which is first developing what we call a task envelope foundation model, which is basically a kind of disembodied consciousness, knowledge base of everything linked to the specific industry, the specific company, and the specific tasks to take. And second, also to have a dexterous operator, a robot, which is for the moment teleoperated because we're using human in the loop. So basically, we try to develop a system to capture, generate, enhance, transfer, exploit all available industry, company, and task-specific knowledge for operator assistance, operator training, and swarm manufacturing. So very quickly, step 1, you would actually take everything you have, like process, product manuals, procedures, quality management, even the 3D digital mockup, which is a 3D, let's say, description with all meta information like tolerance, etc., into the system, including observation of the task, and you would basically build what we call a task envelope foundation models, which you can start interacting in a multimodal, a bit like a GPS, basically helping you to go from point A to point B, helping you with context-dependent information that would come, like a GPS. A GPS doesn't tell you 5 turns in advance to go left. It tells you to go left when you need to go left. And the GPS can even help you if you turn right instead of left, actually drives you back to the right place. So basically, it's a kind of model, it's a kind of tool, this embodied knowledge base that can be used to actually capture, enhance, integrate, exploit all the knowledge available. Second part, this is the teleoperation, where basically we would have an affordable, and here just to give an idea, we put a price tag of 50,000 euro, a bit like, surgical teleoperation, but much more affordable, of course, which would have a number of properties. It doesn't have to look like this, of course, doesn't have to be 3 arms, doesn't have to be 5 fingers. It really depends on the envelope of tasks you need to do. And this is an illustration in a factory where you will have a simple product like laminate that is being assembled by different layers. Still requires a number of certain level of dexterity. And the illustration would be as follows. You would basically build the task envelope foundation model and have a system like you see on the right, like cameras, things like this. Again, it's just an illustration. It doesn't have to look like this. And probably you will have much more sensors. And then it observes a trained operator doing the task and basically compares it to the task envelope foundation models so that it can actually enhance the model. It can compare, well, actually, the way the specialist, the trained operator actually performs the work is different from what is in the procedure. How can we enhance it? How can we make sure, even if there is no procedure, then we would start automatically building the procedure and the instruction manual. But then, of course, you would use it. And again, it doesn't have to be like this. It can be with augmented reality glasses, can be with a screen. New operators or operators actually that are not trained on a specific product, because we talk about here low volume, high mix. So you need to reskill and to upskill operators on many, many different products. So basically the task envelope model, like a GPS, would help you, guide you step by step what to do next. And even sometimes, do quality control, can even stop you, say, look, the fibers are not aligned in the right direction. Stop, because you're not doing the right job. But then, of course, you would have another embodiment, like here, for instance, with a teleoperation. So now it's not just a GPS, but it's also actually the drive-by-wire, so actually manufactured by wire, where you've got the robots that is actually teleoperated by a trained operator. And again, you can compare, but then you can also start measuring much more information. So basically, starting gathering all the data we would need for our end vision, which is the full autonomy. Doing this, the plus point, of course, is then you can start developing some part assistive manufacturing, where, for instance, the simpler task, like, for instance, taking the plies on the left table and removing some of the protection layers and then placing it above the tool, could be done automatically, a bit like driving assistance on the highway. And then when it becomes more complex, then basically the operator takes back the lead. And then other example is like swarm manufacturing, when you will have, like, instead of an operator, you've got a supervisor. Anyway, so let me just go to the conclusion here, because it gives you a bit, the trajectory we do. Why do we do it now? Because basically it's the ChatGPT moment for industrial robotics. It's basically the same moment as, the mainframe computer going to the PC, the laptops, and the iPads. It's now that's happening, and there is something to do, especially for Europe, because in the future, when you look at demography, there won't be anyone to work in factories anyway. So even if, we repatriate the industrial value creation in Europe, you will still need people to work there, but there won't be not enough people to work in factories in the future. So we need robots. But I'd rather buy European robots than American or Chinese robots, where, for instance, Elon Musk is going to decide the price tag of the license to use the robots, or is actually going to decide how stupid our robots are or not. Also, it's important to come from the real applications, to make sure that the gap between the technology providers and the end user is filled. And of course, in Europe, there is a lot of capabilities. As I said, there is a lot of experience, a lot of legacy in automation. We are actually the best in the world in Europe to automate things, and we should continue this. This is really what we need to focus on. And just to link now to the topic of today, which is more also sustainability, how does replacing manual work in automation in the manufacturing industry help or impact sustainability? Well, first point, of course, the repatriation and the maintaining industrial production in Europe helps to shorten physical supply chain. You don't need to move product or semi-finished product from Asia or for South America to Europe. You can actually produce much more locally. So, of course, less transport, less CO2 production. It also fulfills one of the aims of Europe, which is to protect autonomy and prosperity, and also to anticipate, as I mentioned, future labor shortages in Europe, so that we could still maintain production and industrial value creation on European soil. But also, replacing manual work with automation helps to improve the quality, to reduce waste, and to reduce energy consumption, because you get less waste, but also, you don't need to cater for all the human beings around the product. You can just, focus and even turn off the light, if I may say so. So basically, it increases the product and process quality. So you can also decentralize, so you could maybe even have more local production, especially true in low volume high-mix production. You could even think about increasing recycling, because there are a lot of products that cannot be recycled because actually it's too difficult to recycle, or the substances are dangerous, so people cannot touch them. Well, actually with robots that kind of replace the manual work of recycling, you could even go further in recycling. And finally, of course, producing robots has its own carbon footprint. Producing robots consumes material, consumes energy, etc. So if we have more general purpose robots, you can actually reuse them, the same robots, in many different tasks. So actually you have less need for less specific robots, and actually then reducing the need for energy and material consumption, etc., etc. Okay, I'm at the end of it, and I hope this was, useful, very specific on the manufacturing industry, very specific on the manual work in the manufacturing industry, but hopefully, as I could convince you, this is key for the Europe, the sovereignty, sustainability in Europe. So thank you very much, and back to you, Philippe.
Thank you very much for the thought-provoking presentation, Thibault. In a moment, I'll introduce the rest of the participants, but we'll talk a little bit about how we might be able to kind of realize this vision, and also focus on those kind of areas of convergence that need to happen to also accelerate these kind of transitions. So I would ask all the panelists to just turn their videos on. And I will welcome them all to the stage now. So starting us off, we have Gulbul Purabatolian, who is the consulting manager in the IDC for EU, European Government Consulting. She specializes in themes of digital transformation, such as computing, continuing digital platforms, and data spaces. We have Björn Uretsky, from the European Commission, DG Connect. Björn is head of unit for data policy and innovation in the DG for communications, networks, content, and technology that supports the European data economy through various policy initiatives such as the Data Act and the Data Governance Act. Then next up, we have Stefan Martinic, who is a partner at the law firm Kramaric and Partners. He specializes in EU law, tech law, and is situated in Zagreb, Croatia, dealing with a range of issues from corporate, GDPR, IP, crypto, and the upcoming AI Act as well. And then last but certainly not least, we have Antoine Corret, who is the founder of Adra-e and the chairman of Hub AI France, an association whose mission is to promote the rapid growth of the French and European AI ecosystem, and especially the uptake of AI technologies. So thank you very much to all of our panelists for joining today. And I wanted to start with Gulbul. So the computing continuum plays a significant role in building aspects of this vision and also driving the digital transformation. So for those in our audience who don't know, please give us a brief description of what this encapsulates and how you think it can accelerate the vision of AI data and robotics working in unison.
Thank you very much, Philippe. Thank you very much also for having me today. So yeah, I think that part of this has been already perhaps highlighted by the really wonderful speaks of the previous speakers when they were talking about AI at the edge or the robotics. But overall, in summary, when we talk about the computing continuum, we are talking about a comprehensive and integrated computing environment that basically spans from cloud data centers to edge devices to IoT devices. And what this continuum allows us is it lets us to do a sort of seamless processing, storage, and data analysis across the various layers, different layers of the infrastructure, of the computing infrastructure. And this obviously depends on the need that we have in terms of performance, in terms of security, et cetera, et cetera. And so the workload can be distributed to centralized data centers, which are usually ideal for extensive data processing, data storage, data analysis, such as the need that we have for powerful computing capabilities for AI model training, for instance. Or it can be distributed, the workload can be distributed to the edge nodes, which are closer to the device. And this is when we really need applications that need real-time processing and require urgent responses, mission-critical applications. So this is the computing continuum that we talk about. So a layer of infrastructure, horizontal infrastructure of the computing resources. And obviously, when we talk about this computing continuum, we need meta operating systems that can integrate and orchestrate the workload across the different resources that we have in the continuum. It can gives us, I mean, it helps us. The computing continuum helps us in many things, such as it just increases the interoperability, the seamless integration across the cloud, edge, IoT layers. It helps in scalability, so the ability to scale computational resources and data storage from different layers. Also flexibility, because it gives us the adaptability and the possibility to choose that where we want to put the workload on based on the needs that we have. And also resilience, because according to this flexibility, if something happens in one part of the computing continuum, then we are flexible and we are resilient to just move it over to another resource across the computing continuum. So let's say that if we want to look at it from the perspective of the other technologies, it's very important because it just provides a sort of required horizontal layer for deployment of other technologies, complementary technologies such as AI, such as robotics, such as data analytics. And this is something that we have also observed when we were doing our analysis in the EU Cloud Edge IoT initiatives in Unlock CI CSA that we are now currently doing. In the interviews and surveys that we did with the demand side, with the companies, that really the role of complementary technologies such as AI, data analytics, and robotics is crucial for the computing continuum, and vice versa. So they are just like interconnected together. Because as I said, it provides the resources to analyze the data and to process the data. However, what is important here for us maybe is to pay attention that in the computing continuum, the implementation takes place at the use case level, and basically based on the requirements of each use cases. Because it's not the case that for all of the use cases we need edge computing. Basically, what is nice about this paradigm shift of the computing continuum is that for a single use case, we can decide that what part of the functionality can be done in the cloud, what part of the functionality can be done on the edge. And so, but this is nice. This increases the performance. This increases the privacy and security, but it's also very complex. And it brings a lot of complexity with itself. But again, at the use case level, in different areas, it's really crucial. For instance, when we talk about AI, we can think about the case of the autonomous vehicles, that the cloud computing part can be used for training the complex AI models, and then the edge computing can be used to process the sensor data that have been collected, for instance, to decide about the obstacle avoidance or about the path planning. The same for healthcare. For instance, the workload can be distributed among the cloud and edge nodes. In the AI, it can be used for analyze the large-scale medical data, and in the edge, the medical devices that needs the real-time processing of the data. And the same for the robotics. So for the robotics, the previous speaker was talking about the very interesting application of the robotics. And here, I think, again, we come back to the importance of the computing continuum and its strong link with the robotics. For instance, for the manufacturing, obviously we need a sort of distribution of this workload, because what happens is that we can use the cloud computing to facilitate the analysis of the production data, so the data that we collect from the production to optimize the manufacturing processes, predictive maintenance. But on the other side, we need the edge computing also for the robots on the factory floor to perform operations such as assembly, such as welding, quality control in real time and really with a minimal latency. So it's really something that goes hand to hand with technologies such as AI and robotics and data analytics. Then I think what is important here, because here I put the hat also of the coordinator of the Unlock CI project, which is about the computing continuum, is that we see obviously there are many key gaps that need to be addressed by the community in terms of the implementation and deployment of the computing continuum, but such as interoperability, for instance, such as standards and open sources. Skills is a really big gap. Then one clear gap for the adoption is the unclear return on investment of the solutions that are being developed. There are many gaps, but what we have observed is that due to this really strong link between the different technologies, such as AI, such as robotics, such as computing continuum, such as edge computing, these are the gaps that need the joint forces, of different initiatives to tackle these gaps. These are not the gaps that can be tackled only by one initiative, one project, or whatever. It really needs a sort of joint forces between different initiatives that now are running at the European level, like EU Cloud Edge IoT, like Adra, like data spaces, like BDBA. So I think that we have really very interesting work which is happening in the European landscape, but we need to a bit talk more together and collaborate more together to be able to do things together and not in parallel with each other. So I hope that I could address some of the points.
Thank you, Gulba. That was great, really strong messages there of becoming much more tight-knit when it comes to the technologies, but also the communities that support those technologies as well. So it seems, from the kind of common thread between all of the presentations is the importance of data. And so, we hear this association of data as a public good. And another metaphor that comes up quite often is data as the new soil. So it's a fertile medium. It's something that's really important for business to build upon. And in the same way that soil is essential for the growth and cultivation of crops, data is essential for the growth of successful business and for all of these technologies to really develop. So Björn, kind of bringing you in here and tied to this, your unit work on harmonized rules for fair access to the use of data. So Data Act that entered into force on the 11th of January of this year. So it's a key pillar of the European data strategy. But where do you think it will make the biggest impact when it comes to the digital decade objective and advancing the digital transformation?
Thanks, Philip. Thanks for having me. Good to be here. Very interesting presentation from you, Thibaut. I hope I can also refer to that in my remarks. I hadn't heard the metaphor of data being the new soil, to be honest. I heard so far data being the new oil, data being new minerals, but now new soil is something I hadn't heard before. Maybe we should start a competition about metaphors for data. You know, I should ask ChatGPT what it comes up with. Let me just start with a short reminder where we stand with the European data strategy, and then I come back more specifically on your question. So the European data strategy from February 2020 outlines two big pillars. One are the legislative initiatives, and the other one is the funding area. So regarding the legislative initiatives, we indeed have the Data Act. It entered into force in January of this year and will enter application in September 2025. So now this period between January this year and September 2025, companies will use to make their products and services Data Act compliant. One of the key provisions, and again, I'll come back to that later, is this IoT data sharing. So now the end user is in full control of the data that an IoT device generates. So in Thibaut's case, you know, the industrial robot he uses in his industrial setting, he has full control over the data that this robot generates. It's not automatically transferred to the producer of the robot. That's the main change. We also have provisions in the Data Act related to business to government data sharing. So in emergency situations such as a pandemic, we can now get access to privately held data to respond to such emergencies. And we also have provisions in the Data Act related to cloud. So in particular to facilitate cloud switching. And we, for example, foresee to abolish cloud switching charges. And we already see the first successes there as well, since Google and Microsoft have already abolished cloud switching charges as a result of the Data Act. So that's a great success. Currently, we focus a lot on outreach. So we speak to all kinds of sectors, especially to sectors we normally don't speak to, such as the construction industry, to make them aware of the Data Act and the opportunities it offers to them. So we had overall like roughly 40 meetings with industrial representatives, sectors, business associations where we discussed that, and we will continue these efforts. And based on these outreach efforts, we're also currently drafting an FAQ document which will answer the most pressing questions we get from industry. The second legislative instrument that is part of the data strategy is the Data Governance Act. And there I just want to mention very briefly the instrument of data intermediaries that we've created. Data intermediaries are basically neutral data brokers that link supply and demand. So, I mean, for Thibaut's case, he mentioned that, you know, they really need a lot of data. So, I mean, a data intermediary could help you get that data. And I want to emphasize here the neutral aspect. So these cannot really monetize the data they have, other than making the connection between the supply and demand. So they cannot add, like, you know, sophisticated data analytics like we see big tech is doing, and then monetize that. The third instrument is the Open Data Directive. That's all about public sector data. So we have part of that directive entering into application on 9th of June, so roughly 2 weeks ago. And since then, the public authorities are requested or required actually to make free of charge and in a machine readable format 6 categories of high value data sets available. So that's, for example, geospatial data, meteorological data, statistics data, and so on. And you can either check with your local authorities whether they can make this data directly available, or also the EU Open Data Portal where all this is aggregated on an EU level. The second pillar of the European data strategy are these common European data spaces. So a data space is, on the one hand, a technical infrastructure, a cloud infrastructure, and on the other hand, some governance rules, who can access data, how. So there's sometimes this misperception that the common European data space is like a fishing pond and you can, like, you know, suck up all the data you want. But I mean, there are still rules, and you still have to agree between the parties in the data space how data is being shared. We support that in the whole period from 20 to 27 with 750 million euros, so quite a lot of money. And we're deploying or supporting the deployment of data spaces in 14 areas of strategic interest: mobility, healthcare, agriculture, and so on. And just to give you one example of what we're aiming at. So we're also supporting a cancer image data space, and it went live in September 23. And as part of this cancer image data space, we have now a public catalog containing over 200,000 cancer images. And at the end of the project in 2026, it will contain more than 60 million images. I mean, this shows you, I think, also what we have in mind. I mean, 60 million images, you can only get that, I think, on the European level. If you stay on a member state level, you will never be able to scale up to that. And you can imagine the innovation that's possible and also the public health benefit that such a cancer image data space can bring. We've recently published a staff working document on Common European Data Space where we give an overview of all the actions we fund. So if you're interested, just have a look. Of course, it's also important to realize that there are many more initiatives beyond what we are funding. I mean, in the Gaia-X ecosystem, you also have roughly 16 data spaces. I mean, you've probably all heard about Catena-X. Iona-X is another one. And overall, in the whole of EU, we are counting roughly 145 data space initiatives. So I think we are on a good track overall to really unleash the European data economy, both with the legislative initiatives we've put in place and the funding we are providing for common European data spaces. Now a bit more in detail on the Data Act and how this contributes to reaching the digital decade objectives and also to address some of the issues that Thibaut mentioned. So the most important really is this right to access IoT data. As I said, now if you're owning an IoT device, and this IoT device can be anything from your electric toothbrush at home, your private vehicle, the industrial robot, an airplane, a tractor, combine harvester, you name it. It's really very all-encompassing, the Data Act. You as the owner, or if you rent it, or if you lease it of that device, you can control what happens with that data. And you can, for example, also say, yeah, I want to share this data with another third party. And then that third party could develop interesting related services on top of that. I mean, I'm thinking of predictive maintenance, for example, for industrial robots. So in Thibaut's case, you could then pass on the data to another supplier of related services, and this supplier could develop then interesting predictive maintenance algorithms, for example. So this is really what we have in mind. And if you combine that with the idea of data intermediaries, I think you see what we're aiming at. I mean, suddenly you have a lot of industrial data being made available, which you can use for innovation. And of course, I mean, companies like Thibaut's, you can also get or buy completely different data sets from different domains that might be relevant for your manufacturing setting. So we really hope that this will stimulate the European data economy and dramatically increase the availability of data. We also have provisions in the Data Act related to interoperability, especially for European data spaces. So, I mean, the vision is that of the creation of a European single market for data. And for that to happen, of course, the data spaces have to be completely interoperable so that data can easily flow from one data space and from one domain to another. I mean, this is probably where most of the innovation will take place. If you think of manufacturing and mobility, for example, or energy and Green Deal, I mean, there are obvious overlaps, and we have to ensure that the data can flow freely there. We also have provisions in the Data Act related to promoting competitive and open markets and to also address the imbalance in particular SMEs often face when negotiating data sharing contracts. So, I mean, we have certain requirements now laid out in one chapter of the Data Act that companies have to abide by if they deal with SMEs. So in order to prevent some unfair practices in the data economy. And overall, I would say that a lot of the provisions we have in the Data Act really aim at making it easier for SMEs and startups to get more data. I mean, if you just imagine some of the examples in the aviation industry or in manufacturing, it's dominated by some large players, and it's difficult for smaller companies to enter that market. But now, since the owner of the device can decide what happens with that data, they can also decide to give it, of course, to SMEs and innovative startups and really strengthen their market position. So, I mean, in conclusion, I would say it makes it much easier for companies to monetize their data and acquaint themselves with the data and digital economy at large, and it will thus increase the adoption and take up by companies of digital technologies. And this is, of course, one of the main goals of the digital decades, that more companies use digital and data technologies. And I think with the Data Act in particular, we are addressing that goal. One big objective of the digital decade is as well to help innovators scale up faster. And as I mentioned, I think with the Data Act, we directly address that by making more data available that SMEs and startups can use to really develop more better business models, and also then develop more innovations and scale up faster. So I would say this is actually the biggest impact of the Data Act in relation to the digital decade. It's on innovators and how they can develop innovative data-based new services. And yeah, I mean, just in conclusion, ultimately, I think all these measures will help to unleash the European data economy and make Europe a more competitive economy. And we already see the first results, as I mentioned, with respect to the cloud switching, for example. I'll leave it at that, Philippe, but of course, happy to answer any other questions you have.
Thank you very much, Björn. You've really kind of laid out the transformative potential that those data initiatives can have, both from the kind of governance perspective, but also from the kind of operational, infrastructure perspective, and giving giving business access to some of that valuable data that they can turn into real, concrete business applications. So just a quick point, I see the comments coming in on the chat. If you have any questions, please keep them to the end of the session, and we'll hopefully have a little bit of time to also give the audience the opportunity to engage with the panel. So moving on, Stefan, I want to kind of link what we're going to talk about to Björn's presentation here. So, I mean, I want to focus on the EU AI Act. And the potential for that act to offer a kind of comprehensive legal framework that is geared to steering the development and use of AI and to spur innovation. But it also carries a lot of obligations to business that need to comply with the guidelines, classifications, risk management, transparency. And I think also Björn's laid out that there is a very complex interplay of other regulations that are happening in parallel to all of this. There are requirements for intellectual property, GDPR, cybersecurity, etc. It's a very complex interplay, as I've just said. So moving forward, how do you see European industry being able to leverage the potential that comes from AI Act in particular, but also these other kind of the other acts and regulations that are happening in parallel? And so how do they establish a competitive advantage, and how can they overcome some of the requirements that need to be complied with?
First, let me start by telling you some insights which I gained from my participation in the Croatian AI Association, from what I heard from the businesses working in the AI field in Croatia. And surprising for most Croatians, the AI sector, we believe that it's in Croatia is punching over its weight, taking into account the normal economic output of Croatia and also the small size of our market. But what I see a common thread among all those participants and industry leaders from the Croatian AI Association is a bit of fear of the unknown. Some of them see this AI Act and the Europe's regulatory production as, at best, as a double-edged sword. Now, the reason for that is from their mind, I feel is the fear of the unknown of the regulatory burden and the regulatory costs, and how this would impact the AI race, which already it's safe to say that in certain elements, EU is lagging behind the US and China. To all those who are afraid, what I usually say is first, as most of the people following this webinar know, the AI Act is a risk-based act, which means that only the biggest amount of the obligations and the biggest amount of the burden will fall on the high-risk systems. So as much as there is risk, there will be a cost. A particular use case might not have all the regulatory burden. So some of those fears are not well-founded. On the other hand, we can see regulatory activity across the world, from the UK, from the US, India, Brazil, etc. So in a comparison to other jurisdictions, there might be differences in the regulatory cost, there might be difference in the regulatory burden, but I think that difference will not be big enough to fear any potential brain drain, not just from the any bigger than usual, just from the talent or from the companies in this field. And of course, there might be the Brussels effect, which we had with the GDPR, where many jurisdictions such as South Korea, Japan, Brazil, South African Republic, etc., have adopted those provisions. So I would like to put those fears to the rest. On the flip side, what I see, what is positive, and what could be the advantage of Europe is tapping into the fear, not of the companies, but tapping into the fear of the citizens, of the users, telling them that there is a clear, strict responsibilities which come with the AI Act, but not just from the AI Act, which might come potentially from the upcoming AI Liability Directive, which will force and enable all the producers, deployers of the AI to make sure that this AI fits with the European way of life and with our perception of safety and the protection of human rights. And when we say that data is the new oil, soil, whichever metaphor we use, there is still scarcity of data. So the Europe's bet, as the Commission went in that direction and all the institutions together, is that by giving the consumers, the citizens, trust to use data, we might combat this data scarcity, which will allow a bigger footprint, and that the data could be reused in the future development of the AI. And for that reason, I really appreciate from the previous comments, presentation from the fellow panelists, how Europe is going hand in hand, not just with data protection, but data availability. And there are other examples which could help the AI sector in the European Union, such as, for instance, the access to supercomputers, which is another Commission initiative, which will enable quicker and better, more innovative, potentially testing of AI systems to small and medium-sized enterprises. Another specific instrument from the upcoming AI Act, which I would like to point out, is the regulatory sandboxes. And so the provisions of the AI Act state that every member state should have at least one regulatory sandbox. And now, first, for those who don't know, in short, what is a regulatory sandbox? A regulatory sandbox is a system where companies could apply to a public tender to participate in experimentation. Let's say there is an experimentation regulatory sandbox for AIs in the provision of medical services. These elected, let's say, 5 companies would communicate with the regulator before deploying their services. They would gain advice on the interpretation of all the applicable regulation before deploying it, also while deploying their provisions, and after. And in this case, why it's called a sandbox is because if something goes wrong and there is no bad faith, the companies would not be punished. But the point is that both the company would gain from this practice to have a better understanding of how the rules will apply and what will be the specific interpretation of the specific life situation that happens with that specific provision of services. So this gives legal certainty and opportunity to test without consequences their innovative products. But also it might enable the regulator to gain insights how to thread the needle, how to have the best of the both worlds, and to enable and allow innovation in our member states, in the European Union as a whole, without stifling it with over-regulation and over-strict interpretation of the current rules. On our side, from the Croatian AI Association, we are pushing hard on our Croatian government to have not 1, not 2, not 3, not 4, but as many as possible regulatory sandboxes. And I'm inviting anyone listening to this webinar to try to be active in their own member states and push their public sector in that direction. For all these reasons, I believe that all these fears that all this extra regulatory production will stifle our innovation, I think that they're overblown. This is simply our way of life. We shouldn't sacrifice everything on the altars of the profit. And I invite everyone who has any influence to push the public sector, both on the national level and on the European level, to continue with these initiatives such as the regulatory sandbox, the data availabilities, the funding, the access to supercomputers, etc. As if the public sector, rightfully so, is giving a lot of obligations on the private sector, I believe that the public sector should continue offering a hand and helping the AI industry, as we need to work together, both the private and the public sector, to compete in this AI race with the US and China. I'm sorry if I went too much on a political note, even though I'm an attorney, but I couldn't help myself. I'm open to any questions now or later.
Thank you very much, Stefan. Not at all. We'll revisit some of these points in a moment when we come back to questions. We've had a couple from the audience. And yeah, I think, again, kind of very emphasizing the requirement of the public and private sectors working hand in hand to support the understanding, transfer of the knowledge and information, and the kind of practical tools and know-how to make the AI Act and other regulations a success. But I'm going to come to you, Antoine, because you have a lot of personal experience when it comes to setting up your own business and working with the European ecosystem. So you've established 2 of your own companies. And in your opinion, what do you think the kind of greatest challenges are for business when it comes to innovating and when it comes to facing off against the global competition? Because we are in this global marketplace. We are competing against other players in the US and China. So what are your thoughts on this?
Yeah, thanks a lot, Philip, for the introduction. And indeed, if I have only a few words, only one word to say on what is the main challenge for Europe, is that we need the market to be much more open. What I mean is that today, of course, we have a lot of initiatives, we have a lot of research on AI, a lot of impact on the research side and so on. But at the end, European players on the cloud or AI market have, say, between 2 or 5% of the market. And so if we don't open the market, really, it will be much more difficult for scale-up, startup, or even real competition to arrive and to have some European player in 4 or 5 years, not only to have 2% of the market, but to have 20% of the market. So for me, it's really the main challenge. So if I may, if you want to reach that, maybe we could have 3 main points. The first one is that we need Europe to be able to talk at the global level. And one of the things today is that indeed we have a lot of research. We have some first unicorn and so on, like Mistral in France, but we have also Alpha or some other startups into different countries. But at the end, we don't really speak at the global level because we have no infrastructure. Of course, we have a UHPC, but if you take so the first point is the computing power. The computing power, if you take all the UHPC and so on, in Europe, we should have something like a few 10,000, 40,000 GPUs, whereas only Meta will have 500,000 at the end of the year and 1 million GPUs next year. So we have no computing power, which is a real big step, whether for the next step of AI, like neuromorphic AI, like robot large models and so on. So there is really a big challenge on computing power for Europe to be able to speak at the global level. Second challenge, of course, is about data. I don't know whether data is the new oil, the good soil, the real soil, but there is one question in the chat which is about standardization. And of course, you have this question about data, about how you can access data, what is the data market, and so on. But if the data market is ready in 3 years, it will be too late. Because, of course, Meta or OpenAI are already working on new models on the real world. So kind of what we call in the healthcare sector, the real world evidence and so on, but it will be the same in all the other industrial sectors. And so we need to tackle indeed the question of the copyright, because OpenAI is making lots of checks to Axel Springer, to Financial Times, to Le Monde, to PISA, and so on, which is around 100 million per year. So we need to tackle this question about the copyright, and there is no funding for that in Europe, and also about standardization. If we want to be able to have some data sets for lots of industry, because when we talk about large models, we are not talking only about a few amount of data, but about trillion of data. And so if they are not standardized, it will be a big challenge. And my last, maybe the third point is, as you said, how we foster cooperation between private and public, but also between small and large companies. What I mean is that most of the European startups or scale-up are mainly focused or understand the European market, and they are not challenged as much by the US market or by the Chinese market. But when you create more cooperation between global companies like BMW or Volkswagen or LVMH in France, when you talk with them, they consider not the European market, they are considering the global market, so Europe, Chinese, and US market. And so we need to have much more cooperation between small companies and large companies in Europe to be able to challenge these startups and scale-ups, to be at the global level. And so that maybe with something we will introduce later on what we are working on with Adra on this private, public, and small and large organization challenge that we would like to launch in 2025. And my last point is indeed this competition challenge. I think that Europe is quite used to use US solution. And at the end, and you have all this question of competition and of the change, because when you are used to use some solution, it's not that easy to move from one solution to the other. And by the way, you have also competitive challenge because the market is not really open. For example, I will take a very simple example. If you want to use a 365 from Microsoft, it's only available on Azure, and it's a big mess if you want to have your own 365 solution on another cloud, because Microsoft is not such open to that, even if you can easily have a technical interoperability between any cloud and Microsoft 365. It's why the same question on, for example, on OpenAI. They mainly can use OpenAI only on Azure, except for Apple. So why can't some cloud providers use only GPT-4, GPT-4o on their own cloud, and not only on Azure? Why should GPT-4 and 4.0 could not be available on any European cloud providers? So that's what I mean by to be open, and it's the market to be open, but it's also our way of thinking and our way of choosing some solutions that we need to be much more open mind. Where we should have a much more open mindset if we really want to make the European tech industry much bigger.
Thank you very much for that, Antoine. So perhaps this openness that you talk about, the openness of platforms, could be seen as one of Europe's potential comparative advantages in the global stage. What do you think, Thibault? Do you think that this is one possibility of for Europe to develop its own particular niche, or where do you see Europe positioning ourselves in between the kind of global competition? What's going to distinguish us from the rest of the world in terms of the kind of various products that emerge from this technological shift?
Yeah, thanks, and thank you also for all the panelists, because I found the interventions very, very useful, very relevant. And if we go back to the theme of this panel, which is competition, well, basically the world is not going to wait for us, huh? And we can have as many discussions among us, and we can look introspect, but they don't care about us, to be honest, huh? And I don't want to scare people, but I'm personally scared because we keep on talking and we don't do anything. And I go back to my car analogy. There's no point in making traffic regulations and everything there if you don't have highways and if you don't have cars. And that's a bit what's missing here, is that we talk about a lot of regulations, but there are a lot of other things happening. And Philippe, sorry, but I was not planning to share something, but I want to share something more here because I think it's going to be quite relevant for this discussion. Huh? It's this one, because I think it kind of and again, it's about robotics and manufacturing, but I cannot refrain to show it to you because I think it kind of sums up a bit what is missing here. So because we've been discussing a lot about all the great stuff we've got in Europe, huh? A lot of research, a lot of people, talents that go away, actually. So we've got a lot of research laboratories, a lot of software developers, a lot of things that are actually pretty good. Sorry, can you see my screen again? At the same time, we have the industrial end users, like a SAPCA, aerospace, construction. Let's not forget also defense and security, because we never talk about this, huh? But I think defense and security is really a must also to integrate in our reflection, because the big spend in the US, etc., in China is really also about DARPA, about Department of Defense funding. So we shouldn't be shy in Europe to also talk about defense and security, especially with the current, let's say, the current things that are happening at our borders. But there's a gap between this, and actually there misses in Europe a super integrator. And actually, why is Meta, Apple, Google, etc. so successful? Because actually in the digital world, so in the large models, in the foundation models world, not the embodiment, they are the super integrator, because actually they are going to drive to channels to give a purpose to all the developers of technology, because actually it helps Meta, it helps Google, it helps Apple to sell their product better. Actually, we also need a kind of super integrators in Europe, because that's what's missing. And again, we don't have car manufacturers in Europe for AI, like super integrators. So we've got a lot of technologies, but we don't have a channels to go to the market. And this is typical of Europe, of course, because we don't have the same private investment. We don't have the same appetite for risk. At the same time, and that's where we also were discussing, and we're really glad to hear what Bjorn, what Antoine were saying, we also need a fundamental infrastructure. We need actually a common good. We need an infrastructure that is able to have a public service and to promote a strategic public infrastructure that is pre-competitive, that is actually going to manage all the data, to standardize the data, to qualify the data, but also to provide the high-performance computing infrastructure that is needed to be able actually for those ecosystem of technology developers and the integrators to strive and to be able to come to the market. And obviously, all those actors in the chain have to be then able to provide the data in conditions to be discussed. And basically, we all know about the Declare Moonshot, which is promoting like the CERN of AI, which should be at the European level, European Commission level. Again, like a public good. We discussed also, we heard about also like, utility companies. Well, it would be the utility company there. But our point is more than the CERN. It should be actually a mix between an IMEC, an ESA, and an EASA of the data and of, let's say, robotics, combination of AI and the robotics in manufacturing. IMEC for the pre-competitive infrastructure, ESA for the long-term technology roadmap, and EASA for the certification, for the qualification. It's like when you put an airplane in the air, well, there are passengers that are trusting the fact that the airplane is well made, but there are also people on the ground that are trusting that actually also the plane is going to be safe and not going to fall on their head. And at the same time, we need big integrators, like an ASML, like an Airbus, like an Arianespace. These are all champions of Europe that have been built precisely to be the integrator and to channel, to organize, and to focus all the different contributors to a real business. So what is really missing here is actually the full channel, the full link. And that's where I'm getting a bit scared, or let's say a bit worried about the fact that, you know, we discuss a lot, but I don't see so much things happening on that aspect. And that's where, I'm sorry, I'm getting a little bit excited here, but I really feel that time is passing and there is a sense of urgency. There needs to be an action and not just discussion. Europe has been always good in reacting when it's really on a crisis mode. And I think now it's the next crisis, because if we don't capture that challenge, if we don't win that race in manufacturing, in the industry, we are going to miss the big soil, the big oil, the big electricity, the big water, or whatever you want.
Thank you very much, Thibault. Very, very strong words and strong emotions. It's time to do and to act on some of the things that we've been discussing. So we have a couple of questions from participants. In particular, kind of how do we unlock all of this potential? So especially with regards to the question of digital sovereignty and the AI Act. So Björn, perhaps this is one for you. So we're opening up all of the data, but all our plays outside of Europe do not always play by the same rules. And I can think of one example in particular. So in the US, you have this issue of data brokers who are sucking up tons and tons of public, private information, and they're selling that on the kind of open market space. How is Europe viewing this challenge of opening the data differently to other parts of the world?
Yeah, thanks, Philip. I think it's a very pertinent question indeed. I mean, one, I think, important consideration here is as well how we treat so-called gatekeepers in the EU in general. I mean, you've probably heard about the Digital Markets Act, where we impose certain restrictions on big digital companies that are considered to be gatekeepers. And for the Data Act, we picked that up as well. So, I mean, if you're a big tech company and you're considered or qualified as a gatekeeper, you actually cannot access the data that we make available under the Data Act. So I think we've learned that lesson. You know, I mean, they're already very data rich and they don't need much more data. So, I mean, we should really aim at the data poor companies with the Data Act. So I think this is the first consideration. And with respect to data intermediaries or data brokers, indeed, I mean, in the US, anyone can do it. You can sell private data, everything. You can be associated with a big company and then have like a completely different agenda. And for that reason, we are regulating data intermediaries quite strictly in the EU with the Data Governance Act. So during my talk, I mentioned that these companies have to be neutral, for example, so they, cannot basically act on behalf of a larger company that has other interests in mind. It really is about linking the supply and demand of data and nothing else. So I think there we've learned our lesson, and I hope that we address the concerns expressed by the person who asked this question through that. Let me maybe also briefly respond to Thibault's comment, where is the big super integrator? In principle, I agree that we have to do more and we have to act, of course, and I think we have actually acted. I mentioned the cancer image data spaces. I mean, at the end of 2026, 60 million images is not nothing. I mean, this is actually serious business, and this will be available in 1.5 to 2 years. So, I mean, this is, going on for years already. So we are doing stuff there. I'm personally just a bit skeptical of these kind of centralized institutions that we need, like, the one body in the EU that drives all this forward, the one super integrator. I mean, looking at how AI develops, it appears to me to be a very decentralized approach. I mean, also in the US, you don't have this like one body that drove it forward, and you still see OpenAI developing there and not in Europe. So I would argue more in favor of a more decentralized approach, and what we put in place with the data spaces, I think, addresses that, because this is really decentralized innovation that we'll see emerging out of the data spaces. I mentioned the 140, 150 initiatives we have in data spaces. Yeah, this will ultimately drive innovation better, I feel, than having like one centralized data space or one centralized body that drives all these things forward. I think for that, AI is a very different technology, for example, from space launchers or even semiconductors, where you have a very clear technological roadmap, you have big players. There it makes sense to have a more centralized approach. But in AI, it's driven by small startups. I think a decentralized approach is actually more appropriate.
Thank you very much, Björn. On this point, I'm afraid we've run out of time. Sorry, we weren't able to take more questions from the audience, but I have one final ask of all of the participants. So if you can imagine, you can imagine a Europe in 10 years' time that is significantly better off, is in a much better global leadership position. If you could make one recommendation, I know that's quite tough. You can make one recommendation that you think will significantly alter the direction that we are going. What would it be? So first, that question is going to go to Bobo in the first instance.
Yeah, sure. It's not easy, but I think that it's somehow, maybe what I think about is that going to the points that I think everyone raised, the point that we need in Europe to scale up and to go aggressively to the market in order to be able to compete with what's happening in the US and in the China. So I think that this is something that perhaps more support is needed in that regard, you know, in terms of really putting a big support to scale up. And here, I mean, a lot of investment. Obviously, here in Europe, we don't have an environment like US that it's easy to, you know, to absorb the private investments or whatever. But I think that what is really important to understand is that in US, in China, there's a huge amount of money that has been put beside different technologies. You take it from Gen AI, from data, whatever. And I think that in Europe, we have these solutions, but as also Thibaut was saying, we need something in between, you know. So we need the support in order to push this European, to help them, to push them into the competitive market globally, not only in Europe.
Thank you very much. Björn, you're next.
Yeah, I would say that I hope we can sustain the public investments into this area, in data spaces, in AI research, in robotics. Because if you look ahead, I mean, you know, public budgets will be tightly squeezed with demands coming from defense, climate change, and so on. And in general, a more Eurosceptic public that doesn't want to, you know, send so much money to Brussels in general. So I think if we manage to sustain the public investments into AI and robotics, that would already be a good thing, to be honest.
Thank you. Stefan.
Continued openness, learning, and adaptiveness from the regulator. As this technology is rapidly changing, the public sector has to keep on being the first one to this game and to this competition with world regulators, and keep on pushing, continuing with all the investments and everything. But I think we, as the AI landscape will change, our public sector has to change its approach.
Thank you. Antoine. You're on mute.
Philip, because just before I have a network problem, so I didn't catch the question because my Wi-Fi was just off a few minutes.
No problem. So if you can imagine a Europe in 10 years' time that is in a significantly different position, that has enhanced its kind of global leadership position, what would be the one suggestion that you would make, a concrete recommendation that would change the trajectory that we're on currently?
If I have a dream for the Europe in 10 years, is that Europe is really a global tech player with something like with what we have in the telecom, something like a 25 or 30% market share on the tech industries, especially on cloud and AI, of course. And to reach that, I think we should assume what we have on the research side. Today, we are quite shy on accepting that we are really good in the industrial sector and really good in research, but we don't go to the market. So we need to assume that as well as the mindset, but also on the investment side, not only to invest on infra for research, but also to invest on private infrastructure or on large private infra. So if I was doing for Europe in 10 years is that we really have the infra, we should deserve and earn, and we have some real global solutions where we are in the top 3 at the European as a global market share. But once more, I really think that the first step is really to have the infra we deserve.
Thanks, Antoine. And finally, Thibault.
Yeah, quickly, I think you said the word leadership. Leadership means leading, huh? So we should not follow. And I think for the moment, we are much more in a catch-up mode and just following whoever else is doing. I think we should think about one step ahead. And we now go all the way for deep learning, data, computing. What Antoine said is that we don't even have like 10% of the computing. Let's be smart. Let's be smarter. Let's think about another way. So we should lead and we should not follow and try to copy. And we shouldn't also rely only on the public sector. I think we should make sure that businesses can thrive, because things happen only when there is a business, when there is customers, when there is a market. There's no point in pushing regulation if there is no market or if there is no channel to go to the market. So we should also make sure that the infrastructure is there, but also that the soil is there to make sure the seeds are growing from the business side. So we should really take more a market pull than a technology push or a regulation push aspect. So leading, not copying, and make sure that we've got the right ecosystem for the businesses to thrive.
Fantastic. Thank you very much to you and to all of our panelists today. I think it's been a really, really interesting discussion and debates. And yeah, thank you once again. I'm sure we'll be seeing many of you again with Adra in the coming weeks and months. And yeah, thank you very much.
Thanks a lot. See you.
Fantastic. So I think we're going to be moving on to our next session now. Well, it's going to be the exhibition. So we're going to be welcoming our exhibitors to the stage. The first of which will be the AI Networks of Excellence, Eva Dolezalova. So we have a 1-minute pitch for each, and I think we have 7 presentations. Over to you.
So hello, can you hear me? I hope so. Good morning, ladies and gentlemen. It's my great pleasure to open the pitching session today. On behalf of the Vision project, I would like to introduce the European Networks of Excellence Centers, the NOEs, working in the field of AI data and robotics. Funded by the European Commission, these 9 networks form a key element of the AI Made in Europe strategy and bring together the best researchers in Europe. They focus on research and development towards trustworthy European AI, which is human-centric, secure, and beneficial for everyone. These networks bridge the gap between research and industry and can include AI for Media, ELISA, Human AI Net, and Taylor, which will run until the end of this summer, while ELSA, European DAIH, Enfield, and Elias will continue for another 2 to 3 years. Next Wednesday and Thursday, you can learn more about the NOEs. Just use the QR code that you see on the screen and join us for the 4th community workshop and ADA symposium. You can participate in strategic discussions about AI and education, generative AI, and future of AI. Thank you, and I look forward to welcoming you soon at our showroom. Thank you very much.
Thank you very much. Next in line is Alquimia Carmen Perea.
Hello, good morning. My name is Carmen Perea. I am the Alquimia Project Coordinator, and let me introduce you the Alquimia Project. First, an overview of the consortium. In the center of the project, the end user, Celsa Group, with their factories in Poland, France, and Spain, and Fonderia di Torboli in Italy. The German Research Center, BFI, and the Universities of Cardiff in UK and Sant'Anna in Italy. The Foundation Mandat International, the industrial partner Exus as technological provider, and last but not least, Atos as a project coordinator. Next slide, please. The main goal of the project is to build a platform based on federated learning and continual learning to support a greener European metallurgy industry in order to take advantage of the different technologies of artificial intelligence. The project is empowered by the optimization framework tools proposes, assessing the environmental impact of the Alquimia solution and obtaining better product quality, resulting in optimal charge mix and optimal process control. With the following KPIs in mind: reduction of electrical energy input, saving oxygen consumption, increase of metallic yield, less consumption of the oxidation materials, reduction of the wasted material, reduce CO2 emission, and reduce of scrap material, and always placing the human in the very center of the project. Please visit us in our booth. Thank you very much.
Thank you. Next, DS2, Juha-Pekka Soinanen.
Okay, thank you. Could you put the next slide, please? That one. Okay, so I'm Juha-Pekka Soinanen from VTT Technical Research Center of Finland. I'm the coordinator of this DS2 project. DS2 comes from DataSpace DataShare 2.0. And the idea of the project is to develop solutions for enabling DataSpace members from different dataspaces to exchange data. This is a kind of a critical element since dataspaces are defined as an environment where confidential data can be shared between the members. And now the Europe has very kind of different strategies to dataspaces. So one aim is to have a big data economy enabler. And the another one is to create very value creation networks that are based on sharing confidential data. So in our project, we want to kind of provide this kind of a complete data lifecycle sovereignty and governance solution, develop models for data action governance, and have a human in the loop. We want to encapsulate everything into Intersect Dataspace Toolkit. And then we have four use cases for demonstration and validation, where at least in each of those, we have at least 2 dataspaces involved. Thank you very much.
Thank you very much. Next, Manibot, Laura Jones.
Good afternoon. Manibot is advancing the physical intelligence and performance of robots towards human-like bimanual objects manipulation, and our motto is pioneering bimanual mobile robots for challenging work environments. Our goal is to empower bimanual mobile robots with enhanced manipulation capabilities, enabling them to adeptly handle in a human-like manner diverse objects in challenging human-populated environments. We're developing new environment understanding and object pose recognition methods, a novel suite of manipulation primitives, including non-prehensile and bimanual manipulations, innovative cognitive mechatronics, fusing advanced tactile and proximity sensors with the bimanual mobile manipulator, and a new approach for robot cognitive functions based on multi-level robot cycles. We have 2 key use cases, as you can see: supermarket shelves restocking and baggage handling in airports. And our consortium are built of 13 partners from 7 countries, including academic, industrial, and end user partners. And encourage you to visit our booth, and the QR code will take you to our social media and website. Thank you very much.
Thank you very much. Next is Perks and Jon Thomas.
Hi, everybody. I'm happy to introduce the PERCS project. We are dealing with elicitation and exploitation of procedural knowledge in Industry 5.0. And as we are all aware, there are procedural knowledge. They are poorly digitalized and documented. And what we are trying to do is actually offering a solution, a set of digital tools for collecting, managing, and accessing and reusing such procedural knowledge. The way we are addressing that from a technical point of view is to have a combination of symbolic and some symbolic AI approaches in order to model the procedural knowledge, to access and reuse it. We are providing this solution and experimenting with that in 3 use cases from the manufacturing domain. And we are a consortium of a mix of large companies, small companies, universities, research centers. As part of the demo in the booth, I would like to show you our conversational AI platform that we from OnLim are providing as part of the project to show you how you can set up a chatbot using a knowledge graph and LLM technologies in order to access procedural knowledge. So I encourage you to visit our booth and happy to show you a live demo on that. Thank you.
Excellent. Thank you very much. Then we have Recap, Pavel Bourget.
Hello. Recap Testbed Prague is part of the core infrastructure. It's part of the core infrastructure of the Research Center on Advanced Industrial Production, and together with other testbeds in Germany and Czech Republic. It provides a bridge between research and industry and helps transfer research results to applications. Being part of the networks of European digital innovation hubs, testing and experimental facilities, and other European networks of excellence, it is a perfect environment to help companies transform their business. Activities like proof of concept and test before invest can be realized in collaboration with companies to test technologies and solutions before decisions to invest are taken. Testbed infrastructure is also a valuable contribution to research projects within frameworks like Horizon Europe, EIT Manufacturing, and others.
Thank you. And last but not least, Scorpion, Felipe Neves dos Santos.
Yeah. Good morning, everybody. I'm here to present the Scorpion project. The Scorpion project aims to solve the problem of automation and robotics in steep slope vineyards, where we can produce great food and wine. And the aim here was to advance robotics to work in this kind of environment, adding to the SLAM or localization capabilities, the introduction of semantics information to the robot understanding more clear where he is. And also we have added features like putting the robot understanding the steep slopes of the terrains and understanding where the robot can navigate and autonomously and safely. Besides of that, we have bring to this kind of robots that is also novel in this kind of environment is the capacity to understand a prescription map and translate this prescription map in set of actions for the robots to be able fully autonomous make the treatments in this kind of environment. And so this is the kind of novel robots that we are advancing for this kind of fields. So this is the introduction of Scorpion projects, and you are more than welcome to our booth to understand how AI was introduced to this kind of robots. So thank you.
Thank you very much, Felipe, and thank you very much to all of the individuals who presented. Really, really fascinating stuff happening in all of these European projects. So at this point, we're going to move to our coffee break. We initially scheduled it up to 11:45, but I think the suggestion is that we keep it until 11:50 to give everybody the opportunity to top up their coffees and to do anything else they need to in the meantime. So we'll see you back at 11:50, where I'll be announcing the next panel and Look forward to see you there. Bye-bye.